Hello everyone, welcome once again to our channel SR PHARMA GYAN. Today I am going to discuss about the major type of reactions in organic chemistry. I have divided this topic in two parts, part 1 and part 2. I'll recommend that you just see the part 1 first, then go for part 2 video for complete information about the topic. Let's come to the topic. We can divide the major type of reactions into 6 types: substitution reaction, addition reaction, elimination reaction, pericyclic reaction, rearrangement reaction, and redox reaction. In the first video I'll discuss about the substitution reaction and addition reaction. In the second video I'll discuss about the elimination reaction, pericyclic reaction, rearrangement reaction, and redox reaction. Okay, let's come to the first topic, substitution reaction. What is substitution? Substitution is also called as a replacement reaction. Replacement means one atom or group is taking place of another atom and group. There will be a replacement of one atom and group with another. Let's discuss by taking with an example. This is the methane. It contains 4 hydrogens. When we are reacting this with chlorine, this chlorine is replacing this hydrogen. So it is forming a new compound, it is chlorine. So here ultimately what happens, this hydrogen is replaced with this chlorine. This is leaving, going out, and in place of this chlorine is getting in this position. So that is a replacement. That's why it is a substitution reaction. The similar type of reaction we can also observe in aromatic compounds. This is benzene having hydrogen here, which is replaced with chlorine. So that's why it is a substitution reaction. The substitution reaction can also further divide into nucleophilic substitution reaction, electrophilic substitution reaction, free radical substitution reaction. This nucleophilic substitution further can be divided into aliphatic nucleophilic substitution reaction, aromatic nucleophilic substitution reaction, acyl nucleophilic substitution reaction. Similarly, electrophilic substitution reaction can also be divided into aliphatic electrophilic substitution reaction, aromatic electrophilic substitution reaction, and the third type is free radical substitution reaction. I will discuss all the type of reaction by taking examples. Let's come to the first type of substitution reaction, that is nucleophilic substitution. Before going to the nucleophilic substitution reaction, we should know what is nucleophile. Nucleophile, actually it is a Greek word. When you split that word, it comes nucleus and philos. Philos means love. That means any group or any atom having affinity towards nucleus are called as nucleophile. Now what is nucleus? What is the property of nucleus? We know that nucleus are present in the center of the atom, which contains neutron and proton. These neutrons are neutral in charge and the protons are positive in charge. So definitely the total nucleus get positive charge. So any atom or group having love or affinity towards positive charge, they are called as nucleophile. So there are certain property of that nucleophile. So nucleophile may be either negative or it may be neutral. So definitely if it should have an affinity towards positive charge, they must be neutral, or they must be negative in charge. They will be electron rich species. They will be having non-bonding electron in its outermost shell of orbital. They will be having the ability to donate the electrons. They should have the property to donate the electrons. They are Lewis base. What is Lewis base? The atom or a group having the tendency or it can donate electron, those atom or groups are called as Lewis base. Let's come to some example. This is the general symbol of nucleophile. What it denotes? This NU indicates nucleophile. These two dots indicates the extra electron present, non-bonding electron present, and this minus charge indicates that nucleophile is negatively charged. So let's take some example like chloride ion. They are having negative charge, having extra electron, it's this outermost shell of orbital, not extra, non-bonding electron. So this is nucleophile. This is a group, cyanide group, having a non-bonding electron in outermost shell of molecular orbital. and it is negatively charged, OH having negatively charged. So these are some example of nucleophile. Now how nucleophile generates? Say that there will be a heterolytic cleavage. Heterolytic means both the bonded electron, a bond is formed by two electrons. If this both the bonded electrons is transferred to one atom, then it is called as heterolytic cleavage. So when there will be a heterolytic cleavage, then there will be a generation of a negative charge and a positive charge. So this negatively charged atom group or atom called as nucleophile. Let's take an example, NaOH. So this OH having the affinity towards this electron, and Na present at the left hand side of the periodic table, so definitely to get a positive charge. So both the bonded electron is transferred to OH. OH is getting a negative charge, sodium is getting a positive charge. So this is nucleophile. Now what is nucleophilic substitution reaction? In that substitution reaction, when the electron rich species or nucleophile attacks the positively charged or partially positively charged atom in a molecule and replace the existing group, then it is called as nucleophilic substitution reaction. Say that this X is electronegative atom. It generally takes away the bonded electron. The carbon is getting positive charge, X is getting negatively charged. So this nucleophile is attacking that positively charged. As they are electron rich species negatively charged, it will attack the positively charged species of that molecule, and it is replacing the existing group. It's forming a new bond here. So ultimately this nucleophile has replaced this X. So that is nucleophilic substitution reaction. Now come to the subcategory of nucleophilic substitution reaction. The first category is aliphatic nucleophilic substitution reaction. If we split the name, this is substitution reaction. It is a nucleophilic substitution. That means nucleophile will be involved, and if this reaction occurs with aliphatic compounds, then it is a aliphatic nucleophilic substitution reaction. See that this is a aliphatic compound, and here bromine minus forms a nucleophile which is replacing this OH minus. So this is a substitution reaction. OH minus is replaced with bromine. Nucleophile is involved, this bromide ion, and it's happening in an aliphatic compounds. So that's why it is an aliphatic nucleophilic substitution reaction. Coming to the second category, aromatic nucleophilic substitution reaction. So similarly, nucleophile will be involved. It will be replacement of an atom, and this type of reactions occurs in aromatic compounds, then it is aromatic nucleophilic substitution reaction. Say that this is a benzene ring aromatic compound. X is replaced with this nucleophile, so that is replaced with X. That's a nucleophilic substitution reaction. Let's discuss about by taking an example. Here this OCH3, generally it forms OCH3 minus and Na plus. So this is a nucleophile which replaced this chloride ion. So that is a nucleophilic substitution reaction and occurs in aromatic compounds. That's why aromatic nucleophilic substitution reaction. Now acyl nucleophilic substitution reaction. Similarly, it will be substitution. Nucleophile will be involved, and it will be occurred in acyl group. What is acyl group? C double bond O. This is acyl group. Now due to the polarity, negative polarity of this oxygen, this will get positive charge, this will get negative charge due to the polarity of this oxygen. So nucleophile, as it is a negatively charged element, it will attack definitely the positive charged atom of the compound. So it attacks the positive charged compound and attached with that. In the next step, what happens? This X will go out along with the bonded electrons, and these electrons of oxygen will again replaced here and it will get a double bond. So this negative ion will also be neutralized, and these bonded electrons, negative charge bonded electrons, will be forming a double bond. So ultimately what happens here? X is replaced with nucleophile. So this is the example which you can say here the breakage occurs here, which is replaced with this CH3OH, and the new bond forms here. So this is SL nucleophilic substitution reaction. One thing we can consider it here, due to that SL group only the polarity occurs between the carbon and oxygen, and this nucleophile can attack that carbon. That's why the SL group having the affinity for nucleophilic substitution reactions. Now electrophilic substitution reaction. What is electrophile? Similarly, electro loving group, that means electron loving group. Electron we know that are negatively charged element. Okay, so any group or compound having affinity towards negative charge, so they are called electrophile. Affinity towards electron, electrophile. So electrophile must be positive or neutrally charged compound, so that it will be having an affinity towards negatively charged. So generally electrophiles are positively charged element. What is the property of electrophile? It is totally opposite to nucleophile. If you consider this, it is totally opposite to nucleophile. They are either positive or neutral charge. Previously in case of nucleophile, nucleophile was negative. Here electrophile will be positive. In case of nucleophile, it was electron rich species, but here the electrophile will be electron deficient species. In case of nucleophile, it must be having ability to donate electron, but electrophile are ability to accept electron. In case of nucleophile, they were Lewis base. Here electrophiles are Lewis acid. Okay. So this is electrophiles are having totally opposite property that of nucleophile. So here how we can denote electrophile. This is a general symbol of electrophile. E indicates electrophile and the positive charge indicates the charge of electrophile. So example, nitro group, sulfonic acid group, methyl cation. So all are having positive charge. So due to this positive charge, they will be having affinity towards negative charge. So that's why they are electrophile. How it generates? An example, H plus HSO4 minus. So this is electrophile. Coming to the electrophilic substitution reaction. So in this type of reaction, the electrophile or the positively charged electrophile or positively charged element attacks into the molecule to form a new bond by replacing the existing group. So here if you see that this nitration of benzene, this electrophile generated, and this electrophile is replaced this hydrogen. So hydrogen is going out, and in place of this NO2 has replaced. So that is substitution reaction. As electrophile involved, that's why electrophilic substitution reaction. Now coming to the subcategory of aliphatic electrophilic substitution reaction, the first category comes aliphatic electrophilic substitution reaction. So similarly, it will be a substitution reaction, replacement of one atom. Electrophile will be involved, that means positively charged atom or group will be involved, and this reaction will occur in aliphatic compounds. So this is an aliphatic compound. Here chlorine attack, this is a electrophile, and this hydrogen is replaced with this chlorine, the substitution. So these are electrophilic substitution reaction, aliphatic electrophilic substitution reaction. Okay, coming to the second category, aromatic electrophilic substitution reaction. Similarly, electrophile will be involved and the reaction will occur in aromatic compound. See that I have already discussed, this is electrophile, this is aromatic compound, this hydrogen is replaced with NO2. So that's why it is an aromatic electrophilic substitution reaction. Now coming to the third category, free radical substitution reaction. So what is free radical? Free radicals are atom and group which contains unpaired electron in its outermost shell of orbital. The free radicals are formed due to homolytic cleavage of a bond. Previously, what we have discussed, the generation of electrophile and nucleophile was heterolytic. That means both the bonded electron will be shifted to one atom. But free radical forms when there will be a homolytic cleavage. Homolytic means this bond is formed by two electrons. One electron will go to A, another electron will go to B. So these are homolytic cleavage. So A is getting a electron, unpaired electron. B is also getting an unpaired electron. So this is called free radical. Okay, let's take an example. When chlorine in presence of UV light, it generates chloride free radical. Okay, so this is free radical. Now what is free radical substitution reaction? When the substitution reaction occurs by attack of a free radical to an atom and a molecule, then it is called as free radical substitution reaction. Let's discuss it by taking an example. Say that this is the general reaction of methane with chlorine in presence of UV light is forming methyl chloride and HCl. So what happens at the first? UV, in presence of UV light, it generates free radical, and this step is called as formation of free radical. Second step is this free radical will attack the compound. So when it attacks the compound, this chlorine is bonded with hydrogen, is forming HCl, and it generates methyl free radical. So this step is called as chain initiation. Now this free radical will again attack the chlorine. So what happens? This chlorine is attacked with this and attached with this carbon atom, and one more free radical has been generated. So this is chain propagation step. Now this chloride ion can also attack the methyl free radical to form another chloromethyl. So this is chain termination step. Now here we can see the chain formation step, that means formation of free radical, here generating the free radical. Chain initiation means this free radical is initiating the reaction. Okay, so it is forming a methyl free radical, that's why it is a chain initiation step. In the next step, chain propagation, that means this methyl free radical is forming further free radical. So this compound has formed by generating a new free radical, that's why it is a chain propagation step. Now here two free radicals are combining together to form a neutral compound, that's why it is a chain termination, that means completion of the reaction, chain termination step. Okay, so this is free radical substitution reaction. See that ultimately what happens here? One hydrogen has been replaced with this chlorine, that's why it is substitution reaction, and the whole reaction free radical mechanism was followed, or free radical was generated, that's why it is a free radical substitution reaction. Now next come to the next category, that is addition reaction. What is addition reaction? In this type of chemical reaction, two or more compounds will combine together to a single larger compound. That means two compounds will be combining or joining together to give a new and larger compound. Generally, the addition reaction occurs in the multiple bond or unsaturated compounds. So if any double bond or triple bond is present between the carbon molecule or carbon and heteroatoms, they can undergo addition reaction. So it is also a reverse elimination reaction. I'll discuss elaborately by taking an example. Now coming to the major type of reactions. So addition reaction can be divided into nucleophilic addition, electrophilic addition, free radical addition reaction, and cycloaddition reaction. Okay, the first category, nucleophilic addition reaction. Similarly, the addition reaction, if it is occurs by generating a nucleophile and attack this nucleophile to the compounds, then it will called as nucleophilic addition reaction. Here what happens, this is generation of nucleophile. Hydrogen is getting a positive charge. This is a heterolytic cleavage. Okay, the bonded electron goes to nucleophile, this forming a negatively charged. This nucleophile is attacking the compound. So what happens, due to the electronegativity of this oxygen, it is getting a negatively charged and this is getting a positively charged. So due to the property of nucleophile, there is a negatively charged, it will attack the positively charged element of the compound. So this nucleophile is attacking this carbon atom and this is forming a new bond here. And this hydrogen which has been generated, it is attacking this oxygen due to its positively charged. So what happened here is nucleophile is attached with the carbon atom and the hydrogen has attached with this oxygen atom. Now this is a compound and this is a compound. Two compounds reacted together to give a new compound. Nothing is moving out. Two compounds is combining together to give a new and larger compounds. That's why it is an addition reaction. As a nucleophile attacking first to this carbon atom, that's why it is a nucleophilic addition reaction. Okay, coming to the second category, electrophilic addition reaction. That means electrophile will attack first to the carbon atom. So here it's a bromine molecule. So bromine is generating Br plus and Br minus. So this Br plus, this is a electrophile, is attacking to the first carbon atom. So bromine is attached here and generating a positively charged carbon. This is a carbocation. So this Br minus is attacking to this CH2. So here 2 bromine is attached to this bond. Now this is a compound, this is a compound joining together to give a larger compound. Nothing is moving out. So that's why it is an addition reaction. But two compounds, when it is forming, there must have unsaturation in its structure. One thing also noticeable, that in addition reaction, the compound having unsaturation will not remain an unsaturated in its product. So this is the product where there is no double bond. There is no double bond. So this is saturated compound. The reactants are unsaturated and the product is saturated compound. So as electrophile is involved here, that's why it is electrophilic addition reaction. Here nucleophile is involved, that's why it is nucleophilic addition reaction. Now what is free radical addition reaction? As the same, free radicals are the elements having a non-unpaired electron in its outermost shell of orbital is called as free radical. So for that we will take an example. Here the peroxide is there, which will be act as a catalyst for generating the free radical. So this peroxide is divided together by homolytic cleavage and it is forming a free radical. So this free radicals is attacking to HBr, it is forming Br free radical. This is initiation stage. In initiation stage, free radical is generating. Now the second stage is propagation. In propagation, what happens? This bromine free radical will attack the carbon atom. So this bromine is attached here and this carbon got one unpaired electron in its outermost shell of orbital. So this is free radical. So this free radical again attacked by HBr. So there will be homolytic cleavage. This hydrogen will be going to this free radical and this bromine will remain as bromine free radical to attack the next molecule. Now in the termination step, this is again the free radical here. This free radical is reacting with another free radical and it is generating a compound. Okay, so this is termination. That means stop of this reaction. There will be no further reaction because this reaction will not generate any more free radical. Here also another termination step, bromine free radical also can form bromine molecule. In the other first reaction or second stage of this reaction, you will find that there will be a free radical generation to process with the next step, but in this the free radicals are reacting together to give a complete compound, so there will be no further propagation of this reaction. That's why it is chain termination step. Now next is cycloaddition reaction. In the cycloaddition reaction, what is there? There will be addition reaction, but the product is a cyclic compound. Okay, if we see that there are three double bonds which is reacting together to give a cyclic compound. So previously there were three unsaturated bond, but here it is one unsaturated bond. Okay, so these are called as cycloaddition reaction. One thing you have to remember in addition reaction, that the double bond and the triple bond will definitely present, must be definitely present for addition reaction, and in the product this double bond will not remain as double bond, it will be changing to a single bond. Let's come to the summary of today's discussion. Today I have discussed about the substitution reactions and addition reaction. In the substitution reaction, I have discussed with nucleophilic substitution, electrophilic substitution, free radical substitution. In addition reaction, I have discussed nucleophilic addition, electrophilic addition, free radical addition, and cycloaddition reaction. In my second video of this series, I'll discuss about the elimination reaction, pericyclic reaction, rearrangement reaction, and redox reaction. So with this, I just want to discuss some fact here. We know what is nucleophile. They are electrophile. They are positively charged element, and nucleophiles are negatively charged element. What do you know actually? The electrophilic substitution reactions are very common in aromatic compounds, and this nucleophilic substitution reaction is more common in aliphatic compounds. I am saying it's common. Okay, the maximum time aromatic compounds will find that they are following electrophilic substitution. I am not saying that aromatic compounds are only following electrophilic substitution reaction. Okay, now what is the reason? If you see the structure of benzene, it contains three double bonds. So these double bonds are generating a pi electron cloud in benzene. So it is quite difficult for nucleophile. Similarly, they are negative in charge. This nucleophile is negative in charge. It is quite difficult to attack by nucleophiles. At the same time, it is that much easy for electrophile to attack, because electrophiles are positively charged and they are getting pi cloud over here. This is negative. Okay, so that's why electrophilic substitution reactions are common in aromatic compounds. Similarly, for aliphatic compounds, nucleophilic substitution is common. Another fact that I want to discuss in addition reaction and substitution reaction is, in substitution reaction it is not required to presence of double bond, but in addition reaction it is mandatory there the compound must be unsaturated. That means for addition reaction the compound must be unsaturated. That means presence of double bond and triple bond should be present to follow addition reaction, whereas in substitution reaction single bond or double bond both can respond. Okay, with this topic I just want to conclude my video. I'll request you to follow my second video of this series for complete information of different type of reaction. I want to conclude this video with a great saying by Stephen Hawking: intelligence is the ability to adapt to change. Okay, thank you very much for listening.